Hello dear students. So as we have discussed what is an agent and what is a relational agent. Now we will discuss types of agents, agent types in the unit 1 of artificial intelligence course. So let us try to continue with our discussion. This is what we have discussed in the previous session, agents and environments. An agent takes percept from the environment and then it performs some actions using actuators. Agent has got an agent function that maps the percept sequence to the action set. Agent programs is the one which is very important, which implements agent function. The agent function runs on the physical architecture. This is one example of vacuum cleaner world where two tiles are there, tile A and tile B, or location A and location B. If there is a dirt, it sucks the dirt. If there is no dirt, that means it is clean. So it has got a percept of location and dirt. I can write like A comma dirty. So now the action need to be taken is suck. So there are actions left, right, suck, no operation. If there is no dirt, then it will not perform any operation. It will simply sit idle, or it may be moving to the next location. So these are certain actions which it can perform. One simple rule implementing the agent function, we can take it as, if the current square is dirty, then suck. Otherwise, move to the other square. So this is how we can build up the conditions for performing the actions. Now, the structure of agents is completely specified by the agent function that maps the percept sequence to the actions. One agent function or small equivalent class is rational. So agent program implements the agent function. Agent program takes just the current percept as an input. It doesn't consider all the percept sequence. The current percept as a input it considers. Agent needs to remember the whole percept sequence. It will remember the percept sequence but considers the present percept only. And maybe in certain cases, to maintain the percept sequence, it may need some internal memory. That depends on the type of the agent. So agent program types can be like a simple lookup table which will have the sequences of conditions and based on which it can take an action. And then we have these basic types of agent program. In order of increasing generality, we can consider it as reflexive agent types, which are simple reflexive, model based reflex agents. And then we have planning based agents which plan for the future prospects, that is goal. So goal based agents, and then we have utility based agents, and then we have learning based agents which learn from their experiences and improvise their performance measure so that they achieve their ultimate prescribed or supposed goal. So this is the structure of simple reflex agent. Every agent has got the structure, you should remember: environment and agent. Agent takes input from the sensor using the sensors from the environment and does some actions, performs some actions through the actuators it performs. So every agent has got this. Now within the agent, what is there that differs from agent to the agent type. So in case of simple reflex agent, through the sensors, whatever the input it has taken, it is understanding what the world is like now. So based on this understanding, based on the condition action rules, like for example, A is dirty, then suck. So what action it should perform, it will try to understand what action I should do now. Based on that, it performs the action. This is a simple reflex agent. But you should understand, the simple reflex agent, lookup table, condition action rules table would be very large for complicated things like chess, or maybe even for your two-state vacuum cleaner. Number of entries in the action table condition action rules would be very large. As we improve the number of locations, the table goes on improving. So it is not that easy to maintain the table. So this is an example, like select actions on the basis of current percept, ignoring the rest of the percept history. A simple vacuum cleaner agent, if you are taking reflex vacuum agent, location and the status are the percepts and returns an action. If status is dirty, then return suck. Else if location is A, if it is not dirty, then go to right, so it will move to B. If it is already in B, then it will return to left. Likewise, it will go on. So simple reflex agents are simple but very limited intelligence and works only if the correct decision can be made on the basis of the current percept. So current percept requires full observability. And infinite loops in partially observable environment is possible because it is unable to understand what actual the situation is. Now, the next one is model-based reflex agent, where in case of model-based reflex agent, it tries to understand the state. So again, it takes the inputs from the environment through the sensors, perform the actions to the actuators, but in between, it tries to develop what the world is like now. So this is the current state. And then it thinks how the world evolves. So what is the next state? What is the successor state? How, if I do this action, what if I am here, I move 2 steps forward, then I will be 2 feet away from this location, and where if there is a some obstacle, I may hit with it. So what is going to happen and what my actions do? So this it will take into consideration, and based on the condition action rules, it will try to select the action to be performed and performs the action using the actuators. So in case of model based reflex agent, partial observability is also possible because it doesn't know all the successor states, it knows just one successor state. So internal state is based on the percept history. So some sort of history it maintains. Reflects on some unobserved aspects of the current state also. Updating the internal state information requires 2 kinds of knowledge. Knowledge about how the world evolves. So it is independent of the agent. The world evolves by the action. Information about how the agent's own actions affect the world. So how the environment changes if agent performs a particular action. Only determine the best guess for current state of partially observable environment. It tries to determine the best guess for the partially observable environment. That is your model based reflex agent. Now in general, reflex agents choose action based on current percept, and sometimes if it is having memory, based on the memory. May have memory or a model of world's current state. Do not consider the future consequences of their action is. So just look at one step. Now you can think on based on these points, can a reflex agent be rational? Please think in this direction. Then we have planning agents. They will ask what if. So what happens if I do this? So what will be the result, consequence? Decisions based on consequences of actions. Must have a model how the world evolves in response to the actions. Must formulate a goal. What happens if I don't study? I'll fail. So based on that, I'll form a goal. No, I need to gain marks. So I'll change my course of action. Optimal versus complete planning is also possible. And sometimes we may go for replanning also. So this is how the goal-based agent would look like. What the world is like now, based on the state, and how the world will evolve, what my actions will do. So this is based on the current situation. From the current situation, where it can go, what it will be like if I do a particular action, where I will go ahead. So based on this, based on my goal, I will consider the action, what action I should do now. So this is how your goal-based agents would work. Knowing about the current state is not always enough to decide what to do. Situations that are desirable must be specified. So from the current state, where you want to go, that is your goal state. So if you know the goal state, you will move in the direction of your goal. So that is important. Maximizing your performance measure and being a bit rational usually requires such an planning, because to reach the goal, I may be having multiple paths, I may be having multiple solutions. So what solution I should pick up? Somebody say, to clear the exam, I can use cheats, but that is not a rational thing. So there are multiple things. I may be studying 8 hours a day, I may be studying 4 hours a day, I may be studying 16 hours a day. So which is required for what type of subject? To find action sequences, achieving goal. So goal-based agent versus reflex-based agents, if we see, consideration of future would be there. Goal-based agents may be less efficient because they perform one goal, specific goal, but are more flexible. Knowledge is represented explicitly and can be changed easily in case of goal-based agents, based on the goal you want to perform. So going to a new destination, change the destination, it goes to a new destination. So utility-based agents will think about the utility of action they are performing. Like, what will happen if I do this? With that, will I be happy or not? Now, that is a utility factor what they are considering. Same through the sensors, they receive the input. Considering the state, again, the world would look like, and it also takes into consideration of how the world evolves. what my actions do, what it will be like if I do a particular action. Okay, I do this action. Okay, if I put some cheats to pass the exam, what happens? There might be a chance that my cheat is being caught by a invigilator. Now will that make me happy? Will that make my parents happy? So this is point what it is thinking on utility. How happy I will be in such a state. Based on that, what action I should do now, and the actuators using, they will perform the action. So more general performance measure than goals. How happy would each world state make the agent? That becomes the important point. Like goal-based agents show flexibility and learning advantages, the utility-based also will have, and can trade off conflicting goals. Speed and safety, which is better? This is very important. Where none of several goals can be achieved with certainty, we can make use of utility-based agents. So likelihood of success can be weighed by importance of goals. Each goal can be given some likelihood and importance. Rational utility-based agent chooses the action that maximizes the expected utility of action outcomes. And then we have last type, learning agents, which learn, which update based on the sequence of actions they are performing. So there is a performance element. Learning agent changes based on the critique. So it's like reinforcement learning. It is good, it is bad, then you change your actions accordingly. So a problem generator and learning agent based on the learning goals, there is a performance element using which it will take a decision, and through actuators it performs. Learning agents are the most important one, as they maximize their performance measure based on the inputs from the external performance standards, which are given through the critic. Based on the critic, feedback is taken and learning is performed. So these are the different learning agent, the different agent types what we can have. Happy learning. We will continue in the next session.